Okay, your homework questions on page 553. Question 1 says a beam of ions passes through a pair of crossed electric and magnetic fields. E is 6 times 10 to the 5th newtons per coulomb. B is 3 times 10 to the negative 3 Teslas. What is the speed? So E equals VB, so V equals E over B. So 6 to the 5th newtons per coulomb over 3 to the negative 3 Teslas gives you a speed of 2 times 10 to the 8th meters per second. Number 1. Number 2. Electrons moving at 3.6, so their speed 3.6 times 10 to the 4th meters per second must pass through an electric field, E, of 5.8 times 10 to the 3rd newtons per coulomb. How large a magnetic field? So this time you want B. So B is equal to E divided by V. So 5.8 times 10 to the 3rd newtons per coulomb divided by 3.6 times 10 to the 4th meters per second gives you a magnetic field strength of 0.1611 with the ones repeating, Teslas. Number 3. Electrons in a beam are moving at 2.8 times, so V 2.8 times 10 to the 8th meters per second across a magnetic field, E, that is 1.4 times 10 to the 4th newtons per coulomb. What value must the magnetic field have if the electrons pass through undeflected? So E equals VB again, so B equals E divided by V. So 1.4 to the 4th newtons per coulomb over 2.8, so that's going to be a half. It's 10 to the 8th meters per second, and you should get a B of 5 to the negative 5. 10 to the negative 5 Teslas. Okay, number 4 says, oh no, I didn't ask you. You already did number 4 earlier, last week. Number 5, electrons move across a 4 milli, so Tesla. So B is equal to 4 times 10 to the negative 3 Teslas. That M means milli. Magnetic field, they are following a circular path of radius 2 centimeters, so 0.02 meters. What is their speed? So you need the fact that they're an electron, 1.602 to the negative 19 coulombs, and you need their mass, 9.109 to the negative 31 kilograms. Okay, and it wants their speed, so you're going to use R is equal to mv over qb. Rearrange for V, so V is equal to R qb over m. So 0.02 meters, 1.602 to the negative 19 coulombs, and 4 to the negative 3 Teslas, divided by 9.109 to the negative 31 kilograms. And when you do this, you should get a speed of 1.40696 to the 7th meters per second. Okay, that's part A. Part B wants to know what electric field must be applied perpendicular to the magnetic field to keep them from curving. So E equals VB. So that 1.40696, etc., that you have in your calculator to the 7th, you're going to multiply it by the 4 times 10 to the negative 3 Teslas, and you should get an E of 5.6278 to the 4th newtons per coulomb. Number 6. Seems a little weird, but it's here because it's going to come up in the next question. So we're just confirming that you remember this equation because it's going to come up in the other questions this evening. So number 6 says, what energy must be given to an electron to transfer it across a potential difference of 4 to the 5th volts? So V is equal to 4 times 10 to the 5th volts, and the Q is 1.602 to the negative 19 coulombs. What energy? Remember, we're talking about charges, so it'll be electric potential energy. And remember, the change in electric potential energy is also equal to the work done. And so it goes back to that equation that we saw in the preview that we used a fair bit in the first half of the unit, V equals W over Q. So you're looking for W, which is the work done, which is the change in energy. So it's just equal to QV. Okay, so 1.602 to the negative 19 coulombs times 4 to the 5th volts. And when you do this, you get an energy or work done 6.408 times 10 to the negative 14, and energy work done is in joules. Okay, so don't be surprised if you need this one in some of the questions that are coming. All right, so those are your homework questions.